Today is the 17th of November 2023, and this will be our fifth lesson on Pythagoras Theorem. Before I start the lesson, thank you to everyone who has been watching our videos, who have subscribed to our videos, especially those who started with me. Okay, I hope I'm making, if you are writing an exam, I hope I'm shedding some light and making maths a bit easier for you. Okay, please, if you've not considered already, can you subscribe here as a help us share the platform, like, follow, please, depending on which platform you are on. Okay, if you are going to follow and it will cost you, don't. If you are going to subscribe, some platform will charge you, but most platforms, these are free. Okay, and you can share it on the platform you have, because I'm still learning. So some of the platform I haven't heard of it, and I haven't open an account. So if I open an account, then I'll be able to upload some of my videos there. But till then, most all my videos are on YouTube. Okay, and you can get it from Rumble as well. And Twitter, I do share it on Twitter too. So can you help us do that? And it's very important. If the account is not yours, please ask for permission or ask somebody to help you open an account. Okay, you can easily open an account on YouTube, or you can ask somebody to share it with you so that you can watch from the account you have. Okay, thank you very much. You can even share it on WhatsApp. Okay, I do that at times for some people who I want them to just watch and tell me how I can improve. Okay, on the comment section, I normally write please follow my notes/script. Okay, with Pythagoras you have a lot of numbers. Okay, but I have checked this. So like 20, this one here, this is 20.2 all squared. So if you hear 20 all squared, maybe I'm trying to rush through and finish and go somewhere, or maybe I'm expecting somebody to come in, so I'm trying to finish the video so that they don't interrupt. But most follow the notes. Okay, you won't go wrong with my notes and script. And also, I've always used notes when I'm doing presentation or stuff, because it helps you keep on course. You don't divert and talk about necessary things. Okay, thank you very much. Please beware of scammers. Okay, if I have something to say to you, it will be on the video. I wouldn't go through the back door in your account, and then in your messaging you and asking you to donate money to orphanage. I'm not doing that. Okay, if there is a genuine concern for an orphanage and I know about it, and then maybe I might donate, but I don't think I would, because most of my audience are students and most of them are people who want to go back into education, and some of them have even got um, the money. That's what I'm trying to help, okay, so that they can also find whatever they love to do. So please beware of scammers. Recap. We've been doing Pythagoras Theorem. This will be our fifth lesson. Last lesson we solved problems involving squares and rectangle. Okay, I will encourage you to go and watch the video for recap. Start with the introductory. Okay, maths is like a building block, and nothing is so beautiful, nothing goes to waste. So if you understand the basis, it gets from there, because Pythagoras theorem in Gcse is the same as this Pythagoras theorem in A level, and it's the same as Pythagoras theorem at university level. It's just that you will have to, they will make it a bit complex, so you add more and more stuff. Okay, so please watch the introduction, because if you understand the basis, then you can understand where we've done a lot. We've seen how we can apply it to rectangles, isosceles triangle, and today I'm going to show you another way of applying it to real life situations where you might not even have a clue if you look at the question, but you just come out of the exam room and you think, oh, I could have done this, and unfortunately it's over. Okay, so that's why I'm trying to just show you the ways you can look at questions and then decipher how you can use this or that. Okay, now, so watch the videos for recap. Our starter for today: a rectangle has diagonal length of 32.5 kilometers, okay, with width of 20.2 kilometers. This is what we're doing yesterday. Find the length of the rectangle. All my diagrams are not to scale here, okay, so the length, okay, is it has a diagonal length of 32.5, so from there to there is 32.5 kilometers, and the width is 20.2 kilometers here. So they've told you it's a rectangle, and you know the corners are 90 degrees. Yeah, right angles, okay, 90 degrees here. So straight away, to find the length, if you know this diagonal length and you know the width, you can apply Pythagoras theorem here. Okay, so using Pythagoras theorem from the beginning, this is what we've been using: c squared, which is our diagonal, equals a squared plus b squared. Now c squared here is 32.5. Our unit is in kilometers, so our answer will be in kilometers. So 32.5 equals a squared, which we don't know, plus 20.2 squared, which is the width. So a squared will be 32.5 all squared minus 20.2 all squared. A squared will be equal to, if you do this correctly on the calculator, you get 1056.25, which is about right, because 30 squared is 900. So this is about right. 20 squared is 400. So 20.2 all squared, the calculator giving me 408.04 is also about right. Okay, if you do it correctly on the calculator. We've done estimations. Please go and look at it. It will help you if you can know this, because you can, if it's wrong, okay, it's your paper, you can quickly change it, okay, because maybe if you put 21.2 on the calculator, it will give you a wrong answer. So you can quickly change it before you submit your paper. Okay, so now a squared will be equal to 1056.25 minus 408.04. Now we've done this several times, so this is positive, so if it goes to the other side, it will become negative. So that's why we have negative here. So a squared, if you do these two correctly, will give you 648.21. A will be equal to plus or minus the square root of 648.21. Now, because it's length, we are going to choose the positive. So A is 25.5 kilometers, because our unit is in kilometers. Now this is 1 decimal place. Okay, so the length of the rectangle here, this length from here all the way to here will be 25.5 kilometers, 1 decimal place. Okay, now today we want to look at word problems and real life situation problems, how you can apply Pythagoras. Okay, some people might just take a tape measurement and begin measuring. Okay, but you can get the measurement, use Pythagoras Theorem, and say to them, I think this is what the numbers we are working with, which is so cool. Okay, now a sports ground, you know, some of the sports ground are very massive, has been measured as 87 kilometers by 42.7 kilometers. Okay, if a supervisor travels from one corner to the other, how far will it be? Okay, now they've given us two measurements. Initially, if you are not good at this, you wouldn't even be able to think about Pythagoras. But because it doesn't involve time and it involves distance, I will sketch first and see what I can apply, because you've learned a lot of things that you can apply. But they've said a sports ground is measured. Okay, so now 87 by 42 kilometers. So the other side will also be 87 by 42.7 kilometers. Now, If it's a sports ground, maybe they have people coming in to inspect the place, especially if they want to do competitions, maybe international competitions or something, okay, or maybe they need to use it for something. Somebody is responsible for making sure that it's up to the standard. And they say that if the supervisor travels from one corner to this corner, you need to find that distance. He can also travel from this corner to this corner in the other way. If from here to here is 87 kilometers, then from here to there also is 87 kilometers, and from there to there will be 42.7 kilometers. So whichever distance he travels, because he might have to travel, he can't come everywhere, but he have to travel and see and fill his form and see if it is up to standard, so that they can bring in maybe whatever they want to do there. Okay, so now that I have sketched, okay, I know that I can use Pythagoras theorem. If you look at the question, you might not know, because it will tell you it's a rectangle. They just said a ground. Okay, so now that I've got this on paper, I will use Pythagoras theorem. So again, c squared, which is the side opposite to the right angle, equals 87 kilometers all squared and 42.7 kilometers all squared. At the end, I'll bring my units. So here I am. C squared will be equal to 87 all squared plus 42.7 all squared. Now, if I do 87 all squared correctly on the calculator, I have 7569, and then 42.7 all squared will give me 1823.29. So if I add them correctly, I'm going to get c squared will be equal to 9392.29. So c will be equal to plus or minus the square root of 9392.29. Now c will be equal to 96.9 kilometers to 1 decimal place. So this length, this diagonal length, either from here to here or from here to there, whichever the supervisor chooses, he needs to travel 96.9 kilometers. So he can use a car, whatever they use, to make it faster, because this might take a week or two, because in kilometers it's a bit long, and he might not be able to do all in a day, because he might have to be writing as he go along. So the supervisor has to travel 96.9 kilometers for his inspection visits. Okay, so it might take him over a week, because if he doesn't do the right inspection and fill the boxes right and just tick the boxes, if somebody gets hurt, he will have to answer for it and maybe lose his job. Okay, so this is how much the diagonal length it is. So that is one way of getting a real life situation question. Another example, a plane has to travel 289 miles east. So the plane is currently here. He needs to travel this 289 miles east and 108 south to get to a safe landing place. So 108 miles south. So he's here. They've told him to travel east this so many miles and south to get to this point to save. Maybe there is a storm coming, so they want him to be at a safe landing place before the storm comes. But because of his journey, you can see this will make right angles here. Okay, how far will the plane be from where he started? So this is where he is, and he's been redirected to go there. So from here, from this point till he gets the safe landing point, we are supposed to find how far it is. So again, now that I've drawn, I can see that I can use Pythagoras Theorem. So Pythagoras Theorem, we've been quoting it several times from the first video. So by now, you should have it at the top of your mind. Okay, c squared equals a squared plus b squared. Now, he needs to travel 289 miles. Our unit is in miles, so our answer will be in miles. So 289 miles east, all squared, 108 miles south, all squared. These are huge numbers. So if you are doing it on the calculator, be careful you put in the right one. Because if you put 281, you will get a different answer. Okay? And you wouldn't realize it, which you might lose a mark or half mark on. So in situations like this, take your time, use the calculator. That's why you have to be familiar with your calculator now. If you do this correctly on the calculator, you will get 83,521. Okay, if you do 108 all squared correctly on the calculator, you get 11,664. Now if you add them together, you get 95,185. that will be your c squared. So now c will be plus or minus 95,185. So c, which is the positive answer because it's distance, is 309 to the nearest whole number miles, or 308.5 miles to 1 decimal place. So here I'll say therefore the plane will be about 309 miles from where it started the diversion to a safer place. So assuming it traveled from here to there without the storm, he would have just have to go about 309 miles. But because they need to avoid the storm, he needs to go first east and then come south to get to this safe place and maybe wait for the next instruction. Okay, so that is another way of using Pythagoras theorem. Okay. Now there's another example here. To cut some branches off some trees, a 50-meter long ladder is used and safely to support the trimmers. So some local council, at times you see them going around, okay, trimming some of the big trees so that it doesn't fall and cause be a hazard or hit people when there is a storm. Okay, the ladder is 3.7 miles away from the bottom of the tree. Okay, how high will be the trees? Okay, so they have these trees in the area. Now I've drawn my tree. This is under the soil. This is from the top of the ground. This is the ladder here to the where they need to support the tree so that whoever is in the trimming is safe, and it's 15 miles. The ladder from the end here of the bottom of the tree above the ground to this point of the ladder is 3.7 meters. So now they're asking me to find the tree height. Okay, so the tree height is here. So again, by sketching, I can use Pythagoras. So if the workers support the tree this way and climb to this part, then they can be able to get some of the branches off. Okay, so this is what the question means. So straight away, I can use Pythagoras, because if the floor is level and the end of the tree, that will meet at 90 degrees. So here, I don't know the tree height, but I know this length and I know the diagonal, the length of the ladder. Okay, so, and how far the ladder is away from the end of the tree. Okay, so c squared again will be a squared plus b squared. So I have 15 all squared. There we've been given in meters. Okay, so our answer will be meters. 15 all squared will be equal to 3.7 all squared plus b squared. That is the height of the tree that we want, because we want to find the height. And they would have done this before they came out so that they know the measurement and how far they can go on the tree to keep the ladder and the support safe. So b squared now, if you bring it to this side, you have 15 all squared. Now this is positive, so if it goes to that side, it will be minus 3.7 all squared. So b squared, if you do this 15 squared on the calculator properly, you get 225 minus 3.7 all squared will be 13.69. Now if you subtract, b squared will be 211.31. So b will be plus or minus the square root of 211.31. So b will be equal to 14.5 meters to 1 decimal place. The question is in meters. So basically, the tree height would have been 14.5 meters. So they've calculated the length of the ladder and how far away they need to get it so that they can get a good support to trim down the trees. Okay, so the tree are about 14.5 meters high. That is to 1 decimal place. Okay, so if they have it in an area with equal height, after they've done all this, they can safely go and say that, because there are a lot of ladders that they can use. So they wouldn't use the 10-meter ladder, and they wouldn't use the 30-meter ladder. They would rather use the 15 one, so that they can support the workers properly, so that there will not be any incidents. Okay, and these are some of the things you can use. Let's quickly look at another example. A support rope of length 25.3 meters is fitted on the top of a tree house, okay, of height 8.3 meters. Okay, how far is the end of the rope to the base of the house? So there is a tree house. Okay, now some people at times go for retreat and then they go and build a tree house, or maybe they live in the countryside, so they have a spot where they take their families. Okay, maybe 2 of them, they will build it, make it warm and stuff. Okay, or they do it in their backyard. Now this rope supports the tree house from the top there all the way down there. Okay, and it's 25.3 meters. The height of the tree house from the ground to the top there, the apex, is 8.3 meters. Now the question is asking us, so this is the tree house here. Okay, what is the distance between the end of the ground, because the tree house is at the top there. Okay, from here to there. Okay, that's what you are finding. So you know this distance, you know it's at right angle triangle. This height here to the top is been given to you there. So after drawing, I realize again I can use Pythagoras, which is c squared equals a squared plus b squared. So my rope is 25.3 meters, which is here all squared, equals a squared, which is the distance I want from the end of the tree house on the ground to where the rope supports it, plus 8.3 meters, which is from the bottom of the tree house to the top here. So now a squared will be equal to 25.3 all squared. Now if I bring 8.3 to this side, it will become minus. We've done this in 5 videos now, so you should get the point now. Now a squared 25.3 all squared will be 640.09. 8.3 all squared will be 68.89 all squared. Again, estimation. 8 times 8 is 64. So this is about right. So it means my calculator is still functioning properly. Now a squared, if I take this number from that number, okay, I have 571.2. A will be equal to plus or minus the square root of 571.2. So A now will be plus or minus 23.9, to 1 decimal place. Our unit is in meters, so our answer should be meters. So we need to get the roof from the top to the ground, away from the foot of the tree house, about 23.9 meters. That is to 1 decimal place, or 24 meters, which is our nearest whole number. Therefore, the end of the rope should be about 23.9 meters to 1 decimal place, or 24 meters from the base of the tree house. Okay, remember your units again. Okay, and if they ask you to leave your answer in 1 decimal place, 3 significant figures, you know how to do that. We have videos on that. Please go and watch. Okay, so now what have we learned from Pythagoras? If the question involved distance and right angles, you can consider using Pythagoras theorem, especially if you sketch and you can see a right angle, and you can see a diagonal, and you can see one side, or you can see 2 sides with a diagonal and a right angle. Then you can apply Pythagoras. Okay, sometimes you have to sketch to understand the question. So in the questions I've brought you today, the tree house, the plane, the supervisor on the sports field, maybe a swimming pool, maybe they will twist the question, but it's the same principles. So you just have to watch what they are asking you to do. Okay, thank you so much for watching our video today, and I'll see you in the next.